Okay, this is a review for the final in Integrated Math 1. I'm just going to use the reviews that we put together for Module 4, Module 5, and Module 6. I thought about creating new reviews, but I don't think I could create anything better than what we have right here. So you've seen these problems before. Let's make sure we have this stuff mastered. Your final will not be as long as this review, but I will be using bits and pieces throughout it. Alright, so to begin with, we've got to work on our notation for talking about inequalities. Like this is an inequality right here in set notation. -4 is less than x, and x is less than or equal to 2. And then we're going to go to interval notation, and then we're going to graph it. Now, most people are very visual, so I find it easiest to go from the graph. So that's where I'm going to start. And I see that I have a left endpoint of -4 with a less than right there. So I'm going to put an open dot on the -4. And then I have a right endpoint of 2 with a less than or equal to. So at the 2, I'm going to put a solid dot. And since x is anything in between this half closed interval right here, I'm going to do a line between my open dot at -4 and my closed dot at +2. And that's how we graph an inequality. Now, for interval notation, which is what you're going to use most often for the rest of your career in math, all right, we're going to start with a comma, and then you put your left bound, -4 to the left, and your right bound, +2 to the right. Now, you have to have a way to indicate whether it is open or closed. Just like open dot, closed dot. Open dot means I cannot reach -4, and we use a parenthesis to represent that. Closed dot means I can reach +2, so we use a bracket to represent that. Okay, now number 2, they start you with interval notation, so let's put this on the graph. This is the open interval from -4 to +infinity. So my left bound is -4, and it's an open interval, see the parenthesis, so I'm going to go open dot, and then I go all the way to infinity, which is not really a bound because infinity is not a number. So you just draw a line going forever to the right. And now, to do this in set notation, let's go x is, and now we've got open dot going to the right. That means we're greater than, and what is x greater than? The -4. Now, on number 3, they start us with the graph, and this is x is less than or equal to that +2 right there. So let's start with our x, and then you look, we're going to the left, so we're less than that number. The dot is solid, so we're equal, so less than or equal to, and what's the number? The right bound would be 2. Okay, now our interval notation, comma, x is less than or equal to -2, so there's no bound on the left, so that's a -infinity, and the bound on the right is the 2. Now, since we cannot reach -infinity, that has to be a parenthesis. It is open, and since the dot on the 2 is positive, we can reach it, so that's a bracket. And there you go, your first slide. What do you guys think? Okay. Now let's take some equations and let's solve for y. So -5 times y is greater than -40. So we have to undo multiplication with division. Okay, and remember the rule when you're solving an inequality. If you multiply or divide both sides of an inequality by a negative number, you've got to reverse the orientation of your inequality symbol. So this greater than becomes less than. And now over here on the left, the -5's cancel, leaving us y is less than, and a negative over a negative is positive, and 5 goes into 48 times. So y is less than 8. Notice how I do multiple choice too. I don't even look at the answer until I've completed the problem. All right, number 5. Well, I have 6 y's on the left and I have 4 y's on the right. So let's subtract the 4y from each side. Okay, that will not affect my inequality symbol. So 6y minus 4y is 2y plus 10 is greater than or equal to -40. Now, let's get rid of that positive 10 by subtracting 10 from both sides. and that's not going to affect my inequality. So greater than or equal to, I ran out of room over here, and I'm left with 2y on the left, and negative 40 minus 10 more is negative 50. Now I'm going to divide both sides by positive 2, which also will not affect my inequality, so it's still a greater than or equal to, and on the left my 2's cancel, so y is greater than or equal to, and a negative over a positive is negative, and 2 goes into 50 25 times. So y is greater than or equal to negative 25. C. Now, number 6. Well, let's get rid of that 1 right there. So let's subtract 1 from both sides. All right, and I'm left with 2/3 y. Look at how I write this to make things easier. You don't have to do that, but it sure makes it easier for me. And on the right, I have 5 minus 1, which is a 4. And now, how do I undo multiplication by a fraction? You could do this in 2 steps, or easier, let's just multiply both sides of the equation by the reciprocal of 2 over 3. That would be 3 over 2. And the reason we do that is, watch. The 2's cancel, the 3's cancel, leaving me y on the left. And now 2 goes into 4 twice. So I'm going to make that 4 divided by 2 a 2, and 2 times 3 is 6. So y equals 6. Okay, slide number 2 in the books. Hope you guys are having as much fun as I am. Now, it looks like the same problem, but instead of an equation, we have an inequality. And a lot of people could probably look and get right to the answer here, but I'd rather you show every step. So again, I'm going to subtract 1 from both sides, and I'm going to say 2/3 of y is less than 4. And now we're going to multiply both sides by the reciprocal of 2/3. And then we're going to do our canceling. Okay, so the 2's cancel, the 3's cancel, y is less than, and again 2 goes into 4 2 times, so that becomes a 2 times 3 or a 6. Y is less than 6. Some of you may have saw that answer before we did that work, or play in my mind. Okay, so next, well, let's get rid of that 3 right there. So does not affect the inequality. 3 minus 3 is gone, and I have negative 6 times y is less than or equal to negative 33. Now let's divide both sides by negative 6. And when I divide both sides by a negative, I've got to flip this inequality, so less than or equal to becomes greater than or equal to. And the negative 6 on the left cancel, leaving me the factor of y. And a negative over a negative is positive. And I want to simplify the fraction, then 33 over 6. So let me see. 3 goes into 33 11 times. And 3 goes into 6 2 times. So that's going to be an 11 over 2. And the answer is B. All right. Now, this is a literal equation right here, but we're still solving for y. So let's get rid of the 3x's. So I have 3x minus 3x is gone, and I have negative 6y equals, and I'm going to write this in mx plus b form. So negative 3x minus 30. You could write that negative 30 minus 3x if you wanted. All right. Now we're going to divide every term in this equation by negative 6. So equals, and on the left, the negative 6 is canceled, leaving me the factor of y. And on the right, I have negative 3 over negative 6, what would reduce to 1/2, and that's 1/2 of x. So you could write 1/2 x or x over 2. Either way is very appropriate. And then a negative over a negative is positive, and 6 goes into 35 times. And there you have it. Y equals x over 2 plus 5. C. All right, cool. Now, number 10. 10 times the quantity 6 minus 2y is greater than or equal to 160. Now, there's two ways to start this problem. You could distribute the 10 to both terms right there to get rid of the parenthesis. All right, but I always look. See the factor of 10? Doesn't that go into 160? So rather than distribute, I'm simply going to divide both sides by that 10. Either way will work though. So on the left, the factors of 10 cancel, leaving me 6 minus 2y is greater than or equal to 160 divided by 10 would be 16. Get rid of that positive 6 by subtracting 6 from both sides. So negative 2y is greater than or equal to 10. And now divide both sides by negative 2. And do not forget, you divided both sides by a negative, so we've got to flip the inequality. Less than or equal to. The factors of negative 2 cancel, so we have y is less than or equal to negative 5. Positive over a negative is negative, and 2 goes into 10 5 times. Okay, y less than or equal to negative 5? The answer is A. So now let's do the same thing with the literal equation. Divide both sides by 10. On the left, the 10's cancel, so I have 6x minus 2y equals 16. And now let's get rid of the 6x's, subtract it. And I've got negative 2y equals negative 6x plus 16. Can't combine those. Now let's divide every term by negative 2. And there we have it. On the left, the negative 2's cancel, leaving me my factor of y equals negative 6 over negative 2 is a positive 3, because negative 2 goes into negative 6 3 times, x, and a positive over a negative is negative, so 16 divided by negative 2 would be negative 8. All right, so y equals 3x minus 8. Answer is C. Okay, number 12. Graph y is less than 8 on the given number line. Well, let's just put an 8 anywhere we want on this number line. And since I do not have an equal sign, this is open, meaning I need an open dot on the 8. And y is less than that 8. That would be everything to the left of the 8. And there you have it. Solve and graph the solution to 19 is greater than or equal to 1 minus 2x on the given number line. So let's solve for the x right there. Let's subtract the 1. 19 minus 1 is 18, is greater than or equal to negative 2x. And now let's divide both sides by negative 2. And don't forget, we just divided by a negative. So that inequality, we've got to reverse it. Positive over a negative is negative. 18 divided by negative 2 would be negative 9. And then on the right, the negative 2's cancel, leaving the factor of x. And to make this easier to graph, read it from right to left. Always read an inequality from the variable. X is greater than or equal to negative 9. So let's put a negative 9 on this number line somewhere. And you see the equal sign. This is closed, so that's a closed dot. And x is greater than or equal to that negative 9, so that would be everything to the right. Isn't that cool? All right. Write and solve the inequality represented by the given story problem. Katie is saving to take a trip to Hawaii that will cost at least $1,200. So let's write down that $1,200, and we're saying at least $1,200. So at least, wouldn't that be greater than or equal to? So far she has saved $240. So let's put a $240 on the other side. And she adds $120 to her savings each week. And you know, in algebra, we're going to say $120 each week would be 120x. So let's go plus 120x. So there's my inequality. How many more weeks must she save to be able to afford the trip? So now let's just solve this inequality for the x right there. So the 240, let's subtract it from both sides. And I've got 120x equals 960. And then divide both sides by 120, which does not affect our inequality. And on the left, the 120's cancel, leaving the factor of x. And 120 goes into 960 how many times? Now you could punch that out right now. Or you could think, well, 12 goes into 96 how many times? And I don't know, maybe you punch that out. Or, you know, think a little bit. Wouldn't that be an 8? So x is greater than or equal to 8. And what's my unit of measure here? Weeks. 8 weeks. Okay. Number 14. Hope has a saving account with a balance of $840. Okay. And withdraws, so I'm going to subtract from that, $40 per month. And how do we write $40 per month in algebra? 40x. Now, Faith has a savings account with a balance of $120. Let's put that over here. and she's depositing, so we're going to add $20 per month, or 20x. Now, for how many months will Faith's account balance be less than Hope's account balance? So let's make sure we know which expression is for which young lady here. Okay, so on the left we have Hope, and on the right we have Faith. So let's read this one more time. Faith's account balance be less than Hope's account balance. So Faith has to be less than Hope. So I'm going to read this from right to left. 120 plus 20x is less than 840 minus 40x. And now let's solve for the x. So I think I would like to add 40x to both sides. So I'm going to go 840 is going to be 120 plus 20x plus 40x would be 60x. And now let's subtract the 120. Does not affect our inequality. So 840 minus 120 would be 720. And the 120s cancel on the right, leaving 60x's. And then I'm going to divide both sides by 60. So 60 goes into 720, the same as 60, or 6 would go into 72, and that's going to be 12 times. Okay, and on the right over here, the 60s cancel. So x is less than 12. And 12 what here? This is months. So 12 months is greater than x, or x is less than 12 months, however you prefer. Okay, let's get to module 5 now. Write 4x plus 3y is greater than or equal to 12 in slope-intercept form. And you guys know we just need to solve for that y, because slope-intercept is y equals mx plus b. Okay, so let's get rid of the 4x's. Does not affect my inequality, so I have 3 times y is greater than or equal to negative 4x plus 12. Okay, now I'm going to divide every term by positive 3. Does not affect my inequality. So on the left, the 3's cancel, leaving the factor of y. And negative 4x over 3, I'm going to write that as a negative 4/3. And then my x plus 12 divided by 3 would be plus 4. And now let's go down here and see how we did. It's b, isn't it? Okay, number 2. Now standard form. Don't forget, standard form is ax plus by equals c. And a little note off to the side you might put, no fractions and the coefficient of x must be positive. Okay? So, as soon as I see no fractions, you see that 5 right there? I'm just going to multiply that entire equation by 5 to get rid of that fraction of negative 2 over 5. So, 5 times y, I'm going to write 5y. Negative 2x divided by 5 times 5 would be negative 2x. And I wrote that over here so you can see it. The 5's just cancel. Negative 2x. Okay, and then 2 times 5 is 10. Now divide everything by 5. Oh, excuse me, I'm getting standard form here. Good thing I had that up there. So I need ax plus by equals c, so let's add 2x to both sides. And what do we have? 2x plus 5y is less than 10. Ax plus by equals c. That is standard form right there. So 2x plus 5y is less than 10. That's c. Okay. Number 3. Find the x and y intercept of 2x minus 3y equals 16. So let's just do a little intercept table. Just like that. And at the y-intercept, x is 0. So if I let that x be 0, I'm left with negative 3 times what number is 16. Well, negative 3 does not go into 16 evenly. So I'm just going to write that as negative 16, or excuse me, negative 16 over 3. Because all I did was take that 16 and divide by negative 3. Now let's let the y equal 0 to find the x-intercept. So this term is gone, so I have 2 times what number is 16. Well, you guys think about that. You could divide both sides by 2, but you can probably see that. 2 times 8 is 16. So there's my 2 intercepts right there. And I have to look carefully. That is A right there. Number 4. Graph the solution to the system of inequalities right there. Okay, so we need a feasible region. So we're going to start with boundary lines. And these are slope-intercept. So this will be easy. The y-intercept of the first inequality is a 6. 1, 2, 3, 4, 5, 6. And the slope is -2/3. So let's drop 2 and run 1, 2, 3. And then I'm going to get my ruler out. And I see the equals. I'm going to draw a solid line through those 2 points. Okay? Now, the next y-intercept is -4. Right there. And I've got a slope of 1/2 this time. So I'm going to go up 1 and over 2. Right there. And now, there is no equal sign. So this has to be a dashed line through those 2 points. Just like that. And now, I've divided the plane into 1, 2, 3, 4 regions, and I'm going to have to shade one of those regions. Which one? Well, understand what an inequality means. Y is less than or equal to -2/3 x plus 6. That means I have to be below the solid line. Y is greater than 1/2 x minus 4. So I have to be above the dashed line. And the only region below the solid and above the dashed is right there. And there's my solution. Isn't that cool? Okay, now they give us a graph of an inequality and they want us to write it. Oh, I love these, especially when I can clearly see a y-intercept and I have a couple points to find the slope. So I'm going to go slope-intercept because of that. So I'm going to start with my y, and now I look. I am above the dashed line. That means I am greater than. And then I think about my slope. So slope is always rise over run. So we're going to go, the slope is going to be, well, I am rising -2. So I'm going to put the negative out front and a 2. And then I'm running +3. 1, 2, 3. And there's my slope. Now let's not forget about our x right there. And then plus b, where b is simply my y-intercept. And that's going to be a +2 right there. There it is, number 6. For the line 2x minus y equals 12, complete the points. So they've given you 2 points with the x coordinate of each point. So we're just going to solve for the y, all right, with direct substitution. So if x equals 0, I'm going to lose that term, and I have -y equals 12. So you guys, if the opposite of y is 12, doesn't that imply y would have to be -12? And now direct substitution. This one I might have to show a little more work. My x is -1. So I'm going to go 2 times my x, which is -1 minus y equals 12. And that's going to be 2 times -1 is -2 minus y equals 12. Now let's solve for that y right there. So to get rid of the -2, let's add 2 to both sides. And we've got a -y equals 14. Hey, just like before, if the opposite of y is 14, isn't y going to be -14? And there you have it. Now, complete the solution to the system. They have given you the y coordinate of the point where these two equations intersect. So again, you can plug that y coordinate into either equation and solve for your x. So I can put it on whichever one I want. I'm going to put it right there, okay? So I see -x plus 9 times y, which is a 2, equals 14. So that means -x plus 18 equals 14. And then subtract 18 from both sides to get -x equals -4. And again, if the opposite of x is -4, that would imply x is +4. Now, let's check this in the other equation just to make sure. So if x is 4, 5 times 4, isn't that 20? And 3 times 4 is 12. Excuse me, what did I do? The x, oh, I'm sorry, that's the y right there. So 5 times 4 is 20. Don't get too ahead of yourself, Gibbons. And 3 times 2 is 6. Well, is 20 minus 6 14? Why, yes, it is. Worked great. So there's my answer. All right, use elimination to solve the system. Now, simultaneous equations, elimination is my favorite method. And I look, if I add or subtract, can I cancel one of the variables? No, I cannot. So let's manipulate one of the equations so I can. How about we take this top equation and just multiply everything by 2, so we get 4y's. So that's going to be 2 times 2x is 4x, 2 times 2y is 4y, and 2 times 2 is 4. Now I'm going to ignore that top equation for a moment and focus on this system now right here. And because I have negative 4y and 4y, I can simply add them together and cancel my y's. So I've got 4x plus 4x is 8x, and then 28 plus 4 would be 32. Divide both sides by 32. 8 goes into 32 how many times? 32 divided by 8 would be a 4. So the x is a 4. So I'm going to substitute right there. So 2 times x is 2 times 4 plus 2y equals 2. So 8 plus 2y equals 2. Let's subtract 8 from both sides. 2y equals negative 6. And again, same thing. 2 times what number is negative 6? That would be a negative 3. 2 times negative 3 is negative 6. So here's my coordinates. The x is 4. The y is negative 3. Please remember, your x coordinate always comes first in an ordered pair. So I'm looking for 4, negative 3. Answer is C. 10. Solve y equals 11x minus 6 and y equals negative 6x plus 11 by graphing. So now, on this one, they want me to graph the two lines and find the intersection point. We got slope-intercept form too. Okay, so y-intercept, negative 6, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6. Slope, 11, count this carefully. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. And then I'm going to go over 1 right there. Let's see that again. Let's double check that. I looked around a little bit here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and over 1. There it is right there. Now draw the line through those 2 points. Now the next line has a y-intercept of 11. So let's count those carefully. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And now my slope is negative 6, so I have to drop 6. 1, 2, 3, 4, 5, 6, and run 1. And I am right there. Draw your line through those 2 points right there. And the coordinates of that point would be the answer to this system. And what's that x coordinate? Is that a positive 1? And y is 1, 2, 3, 4, 5. Okay, number 11. Write 2 equations and solve the system using elimination. Oh yeah, here's our good one right here. At a local electronics store, some CDs are priced at $14. So I'm going to go $14 times the number of $14 CDs I buy, which I would write as a 14x, while others cost $12. So I'm going to write that as a plus 12y. Okay. Sabrina bought 9 CDs. That does not help me with this first inequality, but she also spent $114. So if she spent $114, I know 14x plus 12y would have to equal 114. Now the second inequality is going to be real easy because she only bought 9 CDs. X for the $14 CDs and Y for the $12 CDs. And so I'm going to go 9 CDs equals 9. And on the left, I'm just going to have an X plus Y. And the question is, how many $14 CDs and $12 CDs did Sabrina buy? So let's solve this with elimination. How about we take this bottom equation right there and multiply everything by 12, so my 12's cancel. So that'd be 12x plus 12y, and 9 times 12, that'd be what? Is that 108? There you go. Now I'm going to cross this out just momentarily so I don't get confused. And I look at these 2 equations, and if I subtract them, my y's will cancel out. So I'm going to go 14x minus 12x would be 2x. 114 minus 108 would be 6. And 2 times what number is 6? That would be a 3. So my x is 3. So if the x is 3, now I'm going to go back to this equation I crossed out. 3 plus what number is 9? The y's got to be a 6. So Sabrina, that was Sabrina, right? Yep. Bought 3 $14 CDs and 6 $12 CDs. 12. Write a system of inequalities for the graph shown at the right. Okay, y equals mx plus b. Here we go. Y-intercept right there. Well, that's going to be a 1, 2, 3, 4, 5. And here's another slope that's perfect on that line right there, or a point. So now I can find my slope. So I'm going to go y is, now, that's a solid line, and I'm shaded below it, so I'm going to go less than or equal to. All right. And then my slope, I am dropping 1, 2, 3, 4, 5. And I am running 1, 2, 3, 4. So my slope is negative 5/4. And don't forget your x. And then what was the y-intercept? It was a 1, 2, 3, 4, 5, plus 5. All right, let's do the other inequality, and we're done. So I have a y-intercept, and now I need to pick another perfect point on that. All the way down here, huh? Okay, works for me. All right, so let's start with our y. And we're above and a dash line, so that's got to be greater than. And then I need my slope again. So this slope would be negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8, negative 9. And I'm running how far? 1, 2, 3, 4. Okay, so there's my negative 9/4, my slope. Don't forget the x. And then what was that y-intercept? Negative 1, negative 2, negative 3, negative 4. And there you have your system right there. Isn't that cool? Okay, hey, we're to module 6 now. So let's find the slope of segment AB. Well, slope is rise over run. And I'm going to put all kinds of formulas on this slide for you guys again. Okay, so I'm going to draw a slope triangle so I can clearly see my rise is going to go 1, 2, 3, 4, 5, 6. And I'm running 1, 2, 3. So let's do our slope. And that would be rise over run would be 6/3, which I'm going to reduce to 2/1. Okay, find the slope of a line that is perpendicular to segment AB. Well, you guys know the concept of perpendicular right there. That is going to be, if slope 1 is perpendicular to slope 2, that means that slope 1, if it was A over B, slope 2 would be negative reciprocal right here. If this is positive, this is negative, and the reciprocal of A over B is B over A. So, what's the negative reciprocal of 2/1? That'd be negative 1/2. Okay, now find the distance between A and B, the length of segment AB. And I'm just going to use Pythagorean theorem right here, and I already have my right triangle right there. Okay? So you guys remember your Pythagorean theorem now. Okay, you've got a right triangle with a leg of 6 and a leg of 3 and a hypotenuse of C. And Pythagoras told us that a squared plus b squared, where a and b are the legs, will always equal the hypotenuse c squared. Okay, so let's fill it in. I'm going to show every step here. So I'm going to call the a the 6. I'm going to go 6 squared plus b is 3, 3 squared equals c squared. So 6 squared is 36 plus 9 equals c squared. So 36 plus 9 is 45. 45 equals c squared. And now let's just take the square root of both sides. Square root of 45 equals the square root of c squared. And now your final answer is, you don't have to simplify the square root of 45 this year. Next year you will. But this year you can just leave that the square root of 45. And the square root of c squared is just a c. Now next year, and we did some of this, but you didn't have to master it, you'd simplify the square root of 45 by going the square root of 45 equals the square root of 9 times 5, and the square root of 9 is 3, so that's going to be 3 root 5. But you can save that for next year. Now write the equation of the line that is the perpendicular bisector of segment AB. So for a perpendicular bisector, we're going to need a midpoint of the segment and then a negative reciprocal slope. We need a midpoint and a slope. Okay, so the midpoint you can probably see very clearly if you look at the graph right here. Okay, and if you're not 100% sure, and that's, I'm not 100% sure, I have a formula for finding the midpoint too. Okay, here's your midpoint formula right here. Okay, x sub 1 plus x sub 2 divided by 2. That is just the average of the x coordinates of your segment plus, and then over here you got a y sub 1 plus y sub 2 divided by 2, the average of your y coordinates. Okay, so what's the midpoint? Well, let's look at point A right here if we want to use that. And that x coordinate is a 2, and the y coordinate is a negative 3. And for B, the x coordinate is a, 2, 3, 4, 5, and the y coordinate is a 3. Now, check this out. And I'm thinking this is 3.50, but let's confirm that. 2 plus 5 is 7. 7 divided by 2 is 3.5. And then y sub 1 plus y sub 2 would be negative 3 plus 3 is 0, and 0 divided by 2 is 0. So if you can clearly see the midpoint, go for it. If you can't clearly see it, you might use your midpoint formula. Now I have everything I need because you guys have point slope form of a line right here. Y minus y sub 1 equals m times the quantity x minus x sub 1. Okay, and by the way, I graphed it too just to double check it right here. So I took my slope, which was negative 1/2. I dropped 1 and I ran 1, 2, and then I draw that line. Does that look like a perpendicular bisector? It certainly does. Let's do our equation now though. So I'm going to go y minus, what's the y coordinate of my midpoint? It's a 0. Equals, what's my negative reciprocal slope to the segment? That was that negative 1/2 up there. And x minus, and what's the x coordinate of my midpoint? 3.5. So there's your equation right there. Okay, yeah, I'm excited too. Oh, this is my favorite right here. Use the diagram below to match the image pre-image listed on the left with the transformations listed on the right. So what I do is I look at the shape and I figure out, do I have a translation, a reflection, or a rotation? Okay, so shape 1 to shape 2. That's the triangle in quadrant 2 to the triangle in quadrant 3. And that, my friends, looks like I must have rotated. So I'm thinking rotation. And look at all my possible rotations over here on the right. They're all rotating about the same point 0, 0, which is right here. So what I'm going to do is I'm going to find the image to this point B right there, which I think would be that point right there, B prime, and I draw a segment from B to my point of rotation, and then a segment from my point of rotation to B prime, and with that I can clearly see that I have a rotation, and that rotation is 90 degrees. Do you agree? And which way? Counterclockwise. So I'm looking for 90 degrees counterclockwise, which is right there. The answer is B. Now, once you've used that, cross it out. You don't need it anymore. Now, next one, 6. Shape 2 to shape 3. 2 to 3. Well, if I look at that, that looks like a reflection to me. So I'm thinking reflection right now. And I see reflected, it could be A or C. So the question is, am I reflecting over x equals 0? So x equals 0 would be the y-axis. Okay, oh, and by the way here, let's go ahead and draw this picture then. So x equals 0, well, where's my b prime going to be? Right there, all right? And now, there we go. Here's the segment from b to b prime right there, all right? Now, can x equals 0, which is a vertical line, be the perpendicular bisector to segment B, B prime? No. So that does not work. How about y equals negative x? Y equals negative x. Well, some of you still struggle seeing this until you put it in slope-intercept form. Do you agree that y equals negative x is the same thing as y equals negative 1 over 1 is a negative x plus my y-intercept b, and that's going to be a y-intercept of what? 0. So let's graph that. The y-intercept 0, and I'm going to go down 1 and over 1. There's my next point right there. And draw that line, and that looks like a perpendicular bisector to me right there. See the 90-degree angle? See that leg congruent to that leg right there? So the answer is C. Oh yeah. Get rid of it. 7. I'm going to go 4 to 2. 4 to 2. Looks like another rotation. So, points of rotation right there. And let's do our little 4 to 2. Let's go a B and a B prime. So there's my point B, making that my point B prime right there. And let's draw our segments. Okay, B to the point of rotation to B prime. And look at that rotation. You agree? That's 90 degrees clockwise. That's E. Let's get rid of it. Okay, 8. Shape 1 to shape 4. 1 to 4. Ooh. What do we got there? I'm thinking rotation again. Uh-huh. And I only have one rotation left. It's 180 degrees, about 0, 0. So let's do our thing right here. Okay. So how about we take that point B to there, and there's my B prime. Draw your segments, and you guys all agree that's 180 degrees right there? 180 degrees about the origin right there. And notice with 180 degrees, they don't have to tell you the direction. Both directions will get you there, counterclockwise or clockwise. So the answer is D. And now, do you think the answer to 9 is going to be A? Well, let's double check. We're going 1 to 3. 1 to 3. That looks like a reflection to me. And the question is, am I reflecting over the line x equals 0? Well, there's my x equals 0 again right there. And that worked perfect. There's my B prime right there. That is it. So there it is. The answer is A right there. Okay, so let's reflect over the line x equals 2. So perform the requested transformations. Make sure to label A prime and B prime. Okay, so x equals 2. Well, x equals 2, that's going to be a vertical line where every x coordinate is positive 2. Now, if they said y equals something, like y equals negative 2, that's going to be horizontal. So that's the horizontal line where every y coordinate is negative 2. So that would look like that. But we want the x equals 2 here, so get rid of that. Okay, and if I reflect over this vertical line, well, isn't that point right there, B, just going to end up right there? And see how that is? That's so nice. B prime. And then A, I'm 1, 2, 3, 4, 5. So let's go 5 more. 1, 2, 3, 4, 5 more right there. And there's my A prime. And that, my friends, is the perfect reflection of segment AB over the line x equals 2. And if we draw a segment like A to A prime or something right there, do you agree that's 90 degrees? And do you agree that that leg is congruent to that leg right there? Okay, right on. Okay, now we're going to rotate 90 degrees clockwise about the point -3, +1. So the first thing I'm going to look for is, can you plot that point right there? Okay, now I'm going to rotate 90 degrees clockwise. Now you remember your trick for 90 degrees? See that point B right there? I need the slope of this segment. because 90 degrees would be perpendicular, and we're going to use negative reciprocal. So A prime does not move. And let's go our definition of perpendicular one more time. If the slope of the first line is perpendicular to the slope of the second line, that means the slope of the first line, if it is A over B, then the slope of the second line would have to be negative B over A. So let's see what we got here. This slope is going to be 1, 2, 3 over 1, 2, 3, 4. And what's the negative reciprocal of 3 over 4? That would be negative 4 over 3. Now, the question is, are we going to put the negative with the rise or the run? So you think about that a second. Picture this rotating 90 degrees. Isn't B prime going to end up right over here? So I'm going to rise negative. So I'm going to drop 4. 1, 2, 3, 4. I'm going to run 3. 1, 2, 3. And there it is right there. And there's my B prime. And there's segment A prime, B prime. The perfect rotation of 90 degrees, and that is in a clockwise direction. Okay? Cool. 12. Reflect over the line y equals negative x. Well, there's our friend y equals negative x, huh? Okay, and don't forget, slope-intercept, that's going to be a negative 1 over 1 times x plus 0. So our y-intercept is 0 for our line of reflection, and our slope is negative 1 over positive 1 right there. Draw your line, and we got to reflect over that. Oh, I love these. Now remember, the line of reflection is the perpendicular bisegment of segment A prime. So this is a slope of negative 1 over 1. What is the negative reciprocal of negative 1 over 1? And that's going to be, well, if this is negative, this is positive, and the reciprocal of 1 over 1 is still 1 over 1. So I'm going to go a rise of 1 and a run of 1. And then I go, oh, look at that. I'm going the wrong way. I got to reflect over this line. So do you agree that 1 over 1 is the same thing as negative 1 over negative 1? So let's try that. Negative 1, negative 1. Am I far enough? No. Do it again. Negative 1, negative 1. Is that one far enough? No, it is not. Let's try it one more time. Negative 1, negative 1. Right there. And that is perfect. That's my A prime. And if you see this segment A prime A, I've got the 90-degree angle right there, and those two legs are congruent. Now, let's do the same thing over here. Negative 1, negative 1. Negative 1, negative 1. Negative 1, negative 1. Is that far enough? No, I need one more. Negative 1, negative 1. And that's my B prime right there. And again, 90 degrees. Look at the length of those two legs. There is my segment A prime, B prime right there. Now, draw the line of reflection that maps P onto P prime. So let's do that first. Okay, so let's start with segment P, P prime. Okay, and now I'm going to need a perpendicular bisector, so I need a midpoint and I need a slope. Now, it looks to me like the midpoint is right there perfectly, but I could use my definition of midpoint too if I wanted to, which is right up there. And that's going to work because look at these points right here. X is negative 2. Y is negative 4. X is positive 2. Y is positive 2. X sub 1 plus X sub 2 would be negative 2 plus 2. That's a 0. And 0 divided by 2 is a 0. Okay, and now same thing with this one right here. Y sub 1, negative 4, plus 2 would be negative 2, and negative 2 divided by 2 would be a negative 1. And I saw that before I even did that right there. Okay, so now, my slope. Well, what's the slope of this line right here? Let's see. It looks like I might have to go the whole way there. Let's go. I'm rising 1, 2, 3, 4, 5, 6, and I'm running 1, 2, 3, 4. So 6 over 4, I would reduce to 3 over 2. 1, 2, 3, 1, 2. Yep. And the negative reciprocal of 3 over 2 would be a negative 2 over 3. So there's my slope. Now I have a slope, I have a point, I'm ready to go. I could go point slope, or that point happens to be a y-intercept, so on this one I could go slope intercept. Let's see if this works right here too. Negative 2 over 1, 2, 3. Yep. Does that look like a perpendicular bisector to you? Sure does. So here we go. Y equals, and my slope was negative 2/3 x plus my y-intercept minus 1. And there you have it. Okay, kiddos, that is the review for your final right there. And I'm going to have you guys working on this while I'm gone this week. And I'm hoping I can get back and go over everything with you and have you guys as ready as possible for your final exam. I hope you've enjoyed my video. And everybody, I miss you all. I'll see you soon. Bye-bye.